welcome to this crowd workshop. This is the last part about shading and rendering. The idea here is to tackle some problems that you might encounter while working with crowds, maybe especially if you're using third-party render engine. It works pretty well with Mantra, and I would highly suggest that you use Mantra. But if for any reason you need to render it in any other renderers, these might be some quick tips that might help you out. Cool. So first I'll make sure that I import all of my agents into a geometry. So by default, I think that if you created this crowd DOP here from the shelf, it'll put down a node inside your crowdsource geo node, which I don't really like. I prefer having a separate geometry, but this is really up to you. So here is the DOP.io. I've already done some other processes here, but the DOP.io basically just takes the result of the DOP simulation, and here you can see that it's set up to only fetch the geometry here. So pretty much like if we were importing a particle system. So rather simple. So here, if I take a look at this animation, great. It's flying, avoiding all the tubes that were there, and it keeps going. So I think I've set up, no, not yet. I'll get another file. But we might want to render this with motion blur, right? Because we want the deformation to really work. So with Mantra, what it does, it has a procedural that would handle the information on the agent primitive to deform the agent properly at render time and then compute the right motion blur. So here I got a couple of examples. Part 2, part 3. Yes, so a couple of examples of renders that I made previously. This is not really a great rendering machine, so renders are there. So we can see, so by default, no motion blur, great. Some of you might want to enable velocity motion blur, but if you do so, what we'll get is the motion blur from the particle itself. So we only get the deformation here, or not the deformation, I mean, we only get the motion blur from the particle moving from the DOP, so it's not really what we want. We don't have the motion blur of the flapping wings here, so not really what we want. So what you wanted to do is just add some samples on the geo motion blur on your RUP or Mantra RUP. So here the procedural takes care of the deformed geometry with the motion blur. It works well. But the problem occurs if you add more samples. I don't know if you would call it a problem, but here I can see that it's working well with 2 samples. Might be because I don't have substeps in my simulation, but here I get this ghosting effect. But I feel like it's not exactly the motion blur that I was looking for. I mean, this is great, this works, but if you're working with a third-party render engine, this might not work. I've tested it with Arnold, and it didn't work. So what you need to do is to unpack all your primitives, your agent primitives, because all the deformation and the motion blur is taken care by a Mantra procedural. And what you need is to unpack, and what I would suggest is to compute the velocity of the unpacked agent and then repack them as different agents or as different packed primitives. So this is an extra step. It's extra computing that is not necessary if you go only through the Mantra way, but this might work with all of your render engine, which is kind of cool. So what I did is I unpacked the geometry. So if I go back to my crowd render here, I got this. If I middle mouse click, I got my 100 packed agents. And here what I did is, just before the packing, unpacking, what I did is I made sure to delete any bad that would go under a certain threshold. So this is just cleanup, post-simulation cleanup. And so I compute the position of all of this, and I delete whatever was under this threshold, but I get the other file here with the motion blur setup. And yeah, so basically what I would do is use the unpack agent sup So it unpacks, it not only unpacks the pack primitive, but really is made for the agent primitive. Get this here. Great. So unpacking the agent here. So now all the points are in the scene. It's live. It's heavy. If I try to play this back, it will not play. Not on this computer. And I compute the trail. So I compute the velocity with a trail node. And then here, it's just a matter than doing a for loop with the piece name here, which is the name from the simulation. So they are all called bat 1, 2, 3, and so forth. And I repack them as pack geometries. And if I middle mouse click here, I get 100 pack geos instead of pack agents. And third-party render engine should be able to read the velocity information from the pack geometries. So this is still better to keep them packed, but as pack geo might work best for you guys. So from there, you'd be able to render it like this with the right velocity and with whatever render engine that you want. So that's one thing. Then you probably want as well to add some variation in the shader. So for this, I would highly recommend using the material style sheet if you're using Mentra again. But if you're not, there might be a couple of ways that we can do some variations without the style sheets. So load this one up. Yes, sure. Great. So I've already prepared a material here, a bat material. And what I did basically is I got the ID from every agent. And I made sure to promote this attribute so it'll be accessible in my material here. And I set up a couple random nodes. So here, the idea is to load up my texture, my diffuse texture here, and color shift it with different values. So I got a random number here for the hue shift, saturation, the value, and all of these random numbers are driven with different seeds. So for all of this, I'm just adding the ID value with a constant value, and this would give me a new number to run the random operation here. So it should give me different values, and with shifts or fit here, I would fit the 0 to 1 distribution into whatever I need to then drive this color correction. So I'll try to render this. Let's see how it goes on this machine. Great. Let's start the render. So I'll just disable this color correction node and fire up the render. And wish for the best. So here is my material assigned. Right. Hopefully I got backup renders. Crowd workshop. IPR. Great. So this was without variation. So I've loaded up the texture. Here how it looks. It's all the same across the board. And with the different shifts here, we got colorful bats. Not really realistic, but again, you could add some variations on, for example, the roughness or any of your maps here. Get some variation without the material style sheet. It's applied overall. It's not targeted to some bats, but let's just dive into the material style sheet, see what we can do. So you'll definitely find online many tutorials about using the material style sheet for crowds. There's one great on the side effects webpage, but for those who've never used material style sheet, it's right there in the data tree. So if we get the data tree here, we can set it up to material style sheet, and then you should get all the geometry in your scene. So what we'll do here is select our crowd render here, and then add a style sheet. So it it can be confusing at first because it's a whole new layout or kind of a new paradigm for Houdini users, because we're used to lay down nodes and tweak the parameters in nodes, but here it's more of a spreadsheet approach. But let's see what we can do. So from this style sheet here, we'll add a new style. So a style would be maybe a way to override some parameters on our shading. So this style, I'll add a target. Since they are packed primitives, we'll target the primitives itself. And we can add an override. So this is really what we want. So we could either set a material. We could change the parameter inside the material. So let's start by just applying a material to all of this. So let's set a material, and its value should be, oh, that's great. Yes. Let's get this batch shader. So again, I'll launch this. And by default, in your mantra RUP, all the material style sheet override should be enabled. And if you want to set different material style sheet to your different RUPs, you can mute some of them depending on the RUP. So you could really do an override for a certain render layer. So here on my RUP node, if I go to shading, I think render here. So apply style sheet or declare style sheet. By default, it's the wildcard, so it's applying all the style sheet, but I could explicitly say what style sheet I need, and or even just removing all the style sheets and get the true render out of my RUP. So let's see here if my style sheet is working. Great, so I've already set up the style sheet, but you can see that I've overridden the material, and let's just explore how this was made. So back to the data tree here, under the crowd render, and I got two different styles. So first is gold and then red gold. So what I did here is I got this override, pretty much like I've just set up 2 or 3 minutes ago, to set a material, and the material that I've set is this material gold. So if I take a look at my materials, this one is a principal shader that I got from the presets here. I left it as it is by default, and that's why all the shaders the shader for all the bats were overridden to this gold material. But if we take a look back to the render, we can see that some bats are red. So what I did then is to create another override as just after, and this one would change the base color parameter from this material. So let's just set it up together here. We can set it to primitive, then override the material parameter. So I'll just remove it and do it with you guys. We'll create a new style. This one here, I'll create an override. The override is the material parameter. I'll change the value, which is I've changed the color, so I'll get the surface here. I think it's basic, and then base color here. So now that I've selected this parameter, it lets me change it. So it fetches the information from the current material. I'll change it to blue. And now I need to add a target. So the target is by default the primitive, but I can set it up to, or I can add a condition on the target, and I could say primitive group, and set it to at ID is smaller than or bigger than 10. So what I should get is whatever primitive that has an ID bigger than Then 10 should get this new blue material. So I've set it to group, but I'm not sure if my attribute is on the groups. Yes, it was on the primitives. But depending on where your attribute is, you might want to set this up to a primitive group or to point group, depending on your attributes. But here is the final result. Based on what you need, you might want to just set different textures, maybe just set a different base color, base diffuse map for every part. And again, just take a look at SideFX website if you want to go more in depth with the material style sheet. And just keep in mind that those style sheets override all of your current materials. So even if you have at the object level here a material assigned on your geometry here, or even inside as a material sup, the material style sheet should override this. All right.
What do you do when you want to use Redshift, though? Because the material style sheet doesn't, you can't just put your amount, substitute out the Redshift.
Exactly. So third-party render engine don't usually support material style sheet. I think that Viri does. But that's why I recommend using Mantra. If you would use Redshift, I would stick with the previous solution, which was in your shading network to drive your material with different random values and then do some adjustment there. But I think the data tree is a good way or a good place to get this overview of your whole scene. But you could have set up materials based on the agent name. You just have to assign them here and then lay down different material subs and then bind your materials to whatever agent primitive that you use. So I think it can be done, definitely. It's just that leveraging the material style sheet lets you do the whole look dev within, like you would have only the render option and the material style sheet, or the render view and the material style sheet, and I think it's a pretty efficient way. Cool. And finally, I just want to show you a quick GIF that I made here. And since this machine is not great for rendering, as we saw, the previous example that I showed you at the beginning of the workshop, the quick render was about 10 seconds. What I did is I sent all of this to Grid Markets. So for you guys who don't know what Grid Market is, it's an online platform for cloud rendering. So it's pretty straightforward. If you want, you can create an account, and I think it comes with 20 credits, which is worth $20. And if you remember the render that I showed you earlier, it cost me something like 10 credits. But like you see, it takes, once you've installed Grid Markets, it takes pretty much like a minute to go through the whole process. And your renders will be sent to a data center, and they will automatically be downloaded back to your computer. So again, this was intended for generalists or small groups of artists who would like to leverage the power of the crowd toolset, but you might not have a render farm. I don't have a render farm at home, so I use the cloud. So that's pretty much it. We still have the mic around if you want to ask questions about this last part or the whole crowd workshop. We still have, I think, 5 minutes for all of this. Thank you.
So what do you do if you want to have hair on your bat? They're fuzzy.
Yeah, fuzzy. Depending on what you want, but you can set up the agents to have the hair, and as a packed agent, it should carry on. I'm not sure if it would work better with Mantra, but it should be inside the agent definition. And just to let you know, all the work files that I used will be uploaded with the video later this week, I guess. But all the files that you saw, if you want to just play with the setup, it will be available. Cool, great. So if anything, I'll be around in the other room, and thank you.